For our first example of using double and half angle formulas and simplifying, we have simplify cosine to the fourth power of theta minus sine to the fourth of theta. And I want to be careful here and put my parentheses where they're supposed to go. So a lot of students ask all the time, and it's a valid question, hey, how do I know when to use double and half angle formulas to simplify? Well, what I would do is actually, first for any trig expression, I would look to maybe use Pythagorean identity or quotient or any other identity we've learned, cofunction, even odd. If those don't work, you probably want to resort to double and half angle formulas, which is why we've done this after those particular lessons. So if you look at this expression and you look at these formulas that we just learned, I mean, there's really nothing that looks like anything to the fourth power. So you're probably thinking, how do I know to use double angle formulas? Or half angle for that matter. Well, looking at the double angle formulas, we do have some trig functions that are being squared. And we know from trigonometry that, or from algebra too even, that you can factor this expression when they have powers of 4. You can use something like difference of squares to boil this down to something simpler. So that's exactly what we're going to do. Okay, so first of all, we want to simplify the trig expression. That is step number 1. In fact, I'm going to give this its own color. So basically, you're just going to take this expression and simplify it using any method we've learned so far. So again, I pointed out that this could be factored, so I'm going to use my variable substitution to rewrite it as x to the fourth minus y to the fourth, where x is cosine and y is sine. You can easily see that here. So next I'm going to factor it using the difference of squares. This will become x squared plus y squared, x squared minus y squared, simply by taking the square root of each of these. Then I will replace them with exactly what I said they were equal to. So x will be replaced with cosine and y will be replaced with sine in each particular case. Now we can use a Pythagorean identity, so like I said, always use those first. Sine squared plus cosine squared is equal to 1, so I'm going to replace it with that. Now the question now becomes, what do we do with the cosine squared minus sine squared? Well, as I said before, the double and half angle formulas involve sine and cosine squared. So we're going to use that to our advantage in order to simplify this expression. And by the way, I do want to point out this is not an easy lesson, okay? However, you need you to follow these steps in order for you to arrive at the right answer. So remember, step 1 is to simplify the expression any way you've learned so far in trigonometry. So go back and review those lessons we learned in Pythagorean identities, factoring, and all that kind of thing. So now we have cosine squared minus sine squared. Now the next step is actually kind of easier, and it's going to be to write the trig expression in terms of one trig function. So right now we have two trig functions. We have cosine and a sine, namely cosine squared minus sine squared. So how do we simplify it in terms of one trig function? Well, that's exactly where the double and half angle formulas come from. I will say this, most of the time we're going to be using double. But anyways, if we go, so we can see that, for example, we have a 2 cosine squared theta minus 1 is equal to cosine of 2 theta. And down here we have cosine of 2 theta equals 1 minus 2 sine squared theta. So one of the applications of double angle formulas is if you have a trig function, you can turn it into the form of another trig function. Like, for example, here's a cosine, but it's equal to something in terms of sine. Okay, also up here you've got 2 sines, and they're both equal to cosine. Maybe you could rearrange it to where you just have cosine of theta equals sine 2 theta over 2 sine of theta. So there's a lot of different ways to turn it into one trig function. And that's what we're going to do here. However, in this particular case, we're going to use Pythagorean identity. And here's how we're going to do it. Since we're left with cosine squared minus sine squared, I can rewrite cosine squared in terms of sine squared using a Pythagorean identity. And that's what I'm going to do here. So here's the original Pythagorean identity. I'm going to underline that in red. We have sine squared theta plus cosine squared theta equals 1. By the way, we are going to use the double and half angle formulas. That's why I was pointing this out. However, before we get to that, we are turning everything in terms of one trig function. And the reason for that is, yes, if you look at this double angle formulas, like for example this one, it's in terms of one trig function. It's 2 cosine squared minus 1. If I can get it to look like that, then I can simplify it even more to just say it's equal to cosine of 2 theta. I mean, we can see the left is simpler than the right. Same for down here. If I can get it just in terms of sine, we can simplify that further into cosine of 2 theta, right? So a lot of times you will use the Pythagorean identities before you even go to double angle. So I'm going to rearrange this and get cosine squared by itself, and I have cosine squared is equal to 1 minus sine squared. It's the same thing as up here, just rearranged. So now I'm going to replace my cosine squared with 1 minus sine squared. Again, the reason I'm doing that is because I want to write the expression in terms of one trig function. So now everything is in terms of sine once I get to this step, right? And now I'm just going to simplify that. If I subtract sine squared twice, that's equal to 1 minus 2 sine squared. And after I've done that, I have completed step 2. I've gotten everything in terms of one trig function. We can already see it's actually simpler than what we started out with. We had powers of 4. It was cosine to the 4th minus sine to the 4th. And now we have just a formula in terms of just one trig function. It's 1 minus 2 sine squared theta. So step 2 is complete. And we did that without even using the double or half angle formulas. We used just Pythagorean identities. So again, as I said before, always use those first. Pythagorean, quotient, cofunction, whatever. Then you will go and you will use the double and half angle formulas. So this leads us to step 3. Write the expression in terms of double or half angle. Now, this is equal to cosine of 2 theta based on this formula that we learned right here. So I'm going to copy that so you can see which formula we used. So we said that cosine of 2 theta is equal to 1 minus sine squared theta. Well, that's exactly what 1 minus 2 sine squared theta. So that's exactly what we have right here. We have 1 minus 2 sine squared theta. Well, that's just equal to cosine of 2 theta. So our final answer is cosine of 2 theta. Basically, we're just taking this and we're saying, oh, it's equal to that because we already proved that. So here is our final answer. And just to reiterate for step 4, if there's any other simplification, go ahead and do that. Now we just have cosine of 2 theta. That's about as simple as it gets. So I'm just going to rewrite, let's use a different color here. I'm just going to rewrite what we started out with. We started out with cosine to the 4th minus sine to the 4th. And we went all the way down and we said it was equal to cosine of 2 theta. Using, like I said, identities we learned first, but at the very end we used the double angle formula to complete the problem. That's it for this particular example, using double and a half angle formulas to simplify expressions. If you have any other questions about this, let me know.